Imagine an online store where every time a customer places an order, you need to process this payment, then update the inventory, and then you need to send a confirmation email confirming that the order was placed. Now, if you try to do this immediately, especially during the peak traffic times, it could slow down the customer experience because in this case we have large amounts of application events and we can't handle all of them all at once. Of course, we could scale up our servers, in this case, to be able to handle these large amounts of application events. But if we don't have to handle all of them at once, it's better to queue these events and handle them later. And this is where we can use message queues. A message queue is a durable component which is stored in memory that supports asynchronous communication. It basically serves as a buffer and it distributes the asynchronous requests. In the basic architecture of messaging queue, we have the input services which are called producers or publishers, which create these messages and publish them to the message queue. And on the other side of this, we have servers called consumers or subscribers, which connect to this queue by subscribing to it. And then they start to consume these messages and perform actions defined by these messages. Now back to our example, instead of handling each task immediately, we can add it to the back of the queue and then send these messages to the servers at a later time. So when an order is placed, the order details are put into a message and then this message is added to the queue with the order details inside. Then we will also have separate processes called workers which pull these messages from the front of this queue and handle these tasks. And for example, if we are processing the very first task, our server acknowledges that it received and also processed this message, and the queue removes this message from the list so that we don't process it again. This is a bit of simple example, but there can be many apps that are writing to the queue, meaning we can have multiple producers, and also on the other side we can have many consumers or servers that are reading from this queue. And the main benefit that this message queue provides us is it decouples these events, which means that this message queue will allow us to process these events asynchronously and we can queue them until we can process them in the consumer. For example, if our consumer is not available to process these messages, our producer can still post a message to this queue. And also if the producer is unavailable to post messages, the consumer can still read messages from the queue and then process them. But what if the message queue crashes instead of producer or consumer? That's another great benefit is that they are durable. If the queue crashes, that data will still not be lost as it is not stored in a RAM, rather it's stored in a disk which is persistent. And that's why it's also reliable. If let's say consumer crashes while reading a message, that message is still in the queue and it will be picked up later when the consumer is online. And of course it also gives us scalability. If you get a flood of orders, the queue just gets longer, but you can process them later when our servers have the capability. Now this example that we looked at is one of the main types of queues, which is first in, first out. These queues are just like a regular line. This means that the last message that arrived will be processed last and the first message that was in the queue will be processed first. Another common type is also priority queues. Some messages might be more important than others, and in this case we can reorder them and we can prioritize these more important messages first. And these queues can also be push-based or pull-based. Some queues are pull-based, meaning they wait for workers or consumers to pull messages from this queue. And on the other hand, some of them are push-based, meaning they actively send messages to the workers to be processed. And common examples of message queues are RabbitMQ, which is a versatile queue that's good for many use cases. We also have Kafka, which is built for high throughput and real-time data processing, and this is great for things like logging and event-driven architectures. And cloud providers like AWS also have their queues. For example, in AWS, that is the simple queue service. It's a fully managed queue offered by AWS, which is scalable and reliable with features like delaying queues and dead letter queues. If you'd like to see how these message queues can be used in action when designing large-scale distributed systems, then you can check out these videos next.